Hey guys, this week in algebra, we are going to start a unit on data, on statistics. So today we're going to look at a few graphs. So our learn and target on today's lesson is what are the different ways I can graph univariate data. So we're going to look at creating and reading dot plots, stem and leaf plots, and box and whisker plots. Another thing I want to do today is if you have this calculator, which hopefully you do, everybody should have it. I'm going to show you how to use it to quickly make yourself a box and whisker plot based on, or graph based on having the lower quartile, the upper quartile, the median, so on and so forth. All right, so the first question we need to say is, what is statistical data? So statistics draw inferences or conclusions about something, about a population, a group of people. For example, companies gather statistics to make conclusions about their customers. So when you're looking at statistics, you are trying to find out about basically patterns of a particular population. There are two different types of statistical data: categorical and quantitative. So categorical would be if I asked you, what are your favorite pizza toppings? Your response would not be a number, would be a word that we could, turn into categories. However, anything that would give me a number to look at is going to be quantitative data. For example, when you take a milestone test, you're answering a lot of questions with words, right? But we take that information, we turn it into a number, a score, which tells us how you performed on the test. So that's considered quantitative data. So the first thing we're going to do is practice drawing a dot plot. So if you think of a dot plot at the bottom where we use our numbers, think of it as a number line. So even if it doesn't include every number from our smallest number to our biggest number, you still have to write every number between our smallest number and our biggest number. For example, I see a 0 and I see a 7. So I'm going to write all the numbers between 0 and 7. 2, 3, 4, 5, 6, 7. Oh, this pen, you guys. So even if a 5 wasn't present, I couldn't skip it because you wouldn't skip a 5 on a number line. The other thing I was going to say is, this is a dot plot. So you could use dots, but I just prefer X's because I just think it's easier to read that way. Now, a lot of people want to try to find the numbers in order and fill them all in numerical order, but don't do that because it's easy to skip a number if you do that. So we're just going to put X's in the order that we see them. So we're going to do 2, 1, 2, 2, 1, 2, 3, 1, 2, 3, 1, 2, 1, 0, 2, 1, 0, 2, 7, 5, 3, 7, 5, 3, 1, 1, 1, 1, 1, 1, 2, 6, 3, 2, 6, 3, 2, 0, 4, 2, 0, 4, 1, 1, 3, 1, 1, 1, 3, 1. All right, so there is our dot plot. Now, one of the things you can tell very quickly from a dot plot is what is the mode. So the mode is the number that occurs the most. So obviously the highest column, which is our 1, shows us what our mode is. It also kind of shows us how our data is distributed. So most of our data points are between 0 and 3. It doesn't look like we have an outlier, but this kind of comes next. But if I draw the outline of my dot plot, it shows us that the majority of the points is between 0 and 3. And then we would say that this dot plot is skewed right because most of the information is on the left, and then the plot kind of fades off to the right. So we would say it's skewed right. So that would affect the mean. So the mean would look a little higher than it probably should be because most of the data is in the bottom numbers. However, we do have several higher numbers. All right, so you guys pause the video. I want you all to practice making a dot plot and then turn the video back on and make sure we agree. All right, so I see numbers 1 through 8, 2, 4, 5, 6, 7, 8. All right, so I have 2, 2, 3, 4, 8, 1, 2, 1, 1. That's the first row. 2, 2, 1, 5, 2, 2, 3, 2, 0, 3, 6, 2, 3, 3, 3, 2. All right, so did you guys get this? If I asked you, if I took away this data right here and I said, how many total people answered this question? Or the question was, the given data represents the number of pets each member of the class has. So if I asked you, how many people did we ask? What would we count? We would count the X's, wouldn't we? Because every X represents one person. So hopefully you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So basically this represents 25 people. So one person has 8 pets. I can't even imagine. If we drew the outline of the dot plot, it would look very similar to the first one that we did. Most of the information or most of the data is to the left, so we would say that it is skewed to the right, skewed right, which would affect the mean. I don't think this 8 would be considered an outlier. However, it would increase the mean just a little bit because most people have between 1, 2, or 3 pets. All right, here we go with our stem and leaf plots. Now a stem and leaf plot, you can use numbers like we have here. You could use decimals, whatever it is that, whatever types of numbers you have, that's what you determine your stems are and your leaves. So basically, since all of these numbers are between 70 and 90, our stems are going to be in the tens place. So we're going to write 7, 8, and 9. So that tells us that well, when we're done, we'll make a key. So we'll know what these numbers mean. All right, so then you look at all the numbers that start with a 7, and then the leaves are the numbers that are in the ones place, and you put them in alphabetical. You put them in numerical order. So what's our smallest 70? So we have a 75. Oh my goodness. We have 3 79s. 9, 9, 9. All right, so did I get all the 70s? Oh, I missed that 50, you guys. All right, so I got to write a 6, even though I don't see a 6. So our top stem should be a 53. All right, I don't see any 60s. I think we got all of our 70s. Let's do our 80s. So I see an 81. Is that the smallest 80? I see an 81. And then I see 3 88s. 8, 8, 8. And then we have several 90s. So I have 2 90s. 90s, and then I have 91, 91, 93, and 94. All right, so I'm going to double count my leaves and make sure that's the same number of data sets I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 2, 4, 6, 8, 10, 12, 14, 15, 16. So I missed one. So let me change colors. You guys, I'm sure already see what I missed. All right, 53, and then we don't have any 60s, but we have 75, 9, 9, 9. All right, what about our 80s? I have an 81, and then I have 88, 88, 88. And then 90s, I have 90, I have a 91, I have a 3, I have, oh, it's that 3, isn't it? Because I marked out the other one. All right, so that's what I'm missing. I should have 2 93s. Whoops. All right, I have 2 93s and a 94, right? 94, good. All right, so what would first of all, I don't know, without looking at my data, I wouldn't know really what these numbers represent. I don't know that the fives, the stems are in the tens place. This could represent the number 5.3, right? So that's why you have to have a key. So you are telling the people looking at your stem and leaf plot what this means. So I'm going to use 5 line 3 means 53. And the key has to apply to this whole stem and leaf plot. So that tells me this number right here is at 79. Now, if I see a blank, this doesn't mean the number 60. It just means that there are no 60s listed because this 0 represents 90, right? What does this number right here represent? It's not a 4, it's a 94. Now, one thing I could do kind of quickly with this is to first of all figure out what the mode is because I'm looking at how I have more what? 9s. Now those two, these 3s and that 3 doesn't count because these are the same number, but this is not the same number. So we would probably say we have 2 modes, which is 79 and 88, right? For the median, I could quickly go from smallest number, biggest, smallest, biggest, smallest, biggest, smallest, smallest, biggest, biggest, smallest, biggest, smallest, and then figure out there's 2 middle numbers. They're both 88. So that means the median is 88. So that's just one way we could figure out what the median is. We could see that the numbers would be mostly larger numbers. So if most data is to the right, we would say that this information, this data is skewed left. All right. So anyway, that's how you create a stem and leaf plot. So you guys are going to create a stem and leaf plot. This represents a sample of grades from my 8th grade class. So I want you guys to use this data here and I want you to make one real quick. And pause the video, please, and then come back. All right, so I see a 4. I don't see any 5s at this point in my life. Here's 60, 61, 60, 61, 63, 64. Oh, there's a 65. All right, what about 70s? Do you see a 70? I see 2 74s. 74, 74, 76, 76. Did I get that 68? No, I did not. All right, what about my 80s? I have an 80, I have an 81, I have an 82. I have an 83. I have 2 89s, 9, 9. Oh my goodness. And then, all right, so, so sorry. Did you count your leaves to see if you got them all? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18. So make sure you always count to make sure you don't miss something. All right, so you can use any, it doesn't have to be the top one. So 4 line 9 means, or you could put equals 49. All right, so I think our information would be probably skewed left, even though it's almost the same, isn't it? There's no 50s, but this would be really close to being symmetrical. All right, now we're gonna make a box and whisker plot. So there's several different things you have to do first. The first thing you would do if you're doing it by hand is you would have to put the numbers in numerical order. That helps you determine the smallest number and the biggest number, which is 2 things you need. And then you would need the inner quartile, the first quartile, which is called the lower quartile or quartile, the first one. And then the upper quartile would be the third quartile. And then we need the median. All right, so let me show you how to do that. So the first thing we're gonna do is put these numbers in numerical order. So I see a 35. I see a 39. I see a 40. I see a 42. I see a 45. a 46. I see a 49, 50, and 55. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, which means I have, since it's odd, I have one middle number. So I have 1, 2, 3, 4. 1, 2, 3, 4. So my median is 45. Now I have a set of, first of all, if I had an even set of numbers, I wouldn't circle the one middle number. That means I would have two middle numbers. So I would draw a line between the two middle numbers. If I had two middle numbers, I wouldn't circle anything. I would find the average of the two middle numbers if there were two of them. All right, so now I have four lower numbers. I need to know what the median of these four lower numbers is. Well, I have two middle numbers. So halfway between 39 and 40 is 39.5. Here, the two middle numbers is 49 and 50. So my upper quartile, or my third quartile, is 49.5. All right, so once again, we need a number line, and number lines don't skip numbers, right? Well, my data ranges from 35 to 55. So I could number by ones, but that would be awful long. I could number by twos or threes, even by fives, 35, 40, 45, 50, 55. That's only 5 spaces. So let's do by threes. So we'll do 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 53, and 56. All right, so anyway, so you want your box of your box and whisker plot to be around the first and third quartiles. So 39 and a half would be right between 39 or 38 and 41. That's 39 and a half. And then 49 and a half would be really close to 50, right? There's my box from our lower quartile or first quartile to our third quartile. And then the median is a line through my box. So the median would be about 45, about right there. So there's my box, and my whiskers point to my smallest number and my biggest number. My minimum, 35, and my maximum, which is 55. All right, and there is my box and whisker plot. Okay, it's not totally non-symmetrical. The median is more to the right, so we would probably say this is skewed left. And so one thing, if I didn't have my data up here, you know, a box and whisker plot tells you, basically this divides your data into 25%. So 25% of my data is between 35 and 39 and a half. The upper 25% of my data is from 49 and a half to 55. The middle 50% of my data is between 39.5 and 49.5. The median of my data is 45. So you can see a lot quickly through the box and whisker plot. One thing that's kind of a negative, if you don't see the data, let's say all that data is gone, you really don't know how many sets of data are part of your set, your entire, you don't know how many people were included in the survey, is what I'm trying to say. And so that is one of the negative things. You can definitely tell me people were part of the survey in box and dot plots, right? All right, now one thing, oh, it tells you what to do. All right, so let me show you with a calculator. Now I had to do all that by hand, which is no big deal because there wasn't a lot of data sets. However, if I didn't have, if I had a whole lot of numbers and I was doing all that by hand, that would be a lot of work, putting them all in order and then, you know, figuring out the smallest number, the median, the lower quartile, the upper quartile. All right, so I'm going to show you how to use your calculator. So we're going to use that data we just looked at. So we're going to follow these directions, and you have a copy of my these notes, right? All right, so on this calculator, there is a data button. Do you see it? It is right above, where is my data button? It's below the delete button. So it's on the second row right there, data, okay? So you're gonna hit data, and then it says you're going to list all of the numbers under the very first column. Very first column. All right, so if you need to clear your calculator, hit clear and on at the same time. And then to get those words off your screen, hit clear. All right, so hit your data button. There's 3 columns. Under the first column only, we are putting in all of that data. We're going to type in 45, enter, 40, enter, 35, enter, 49, enter, 50, enter, 55, 42, 39, and 46, enter. Now, we're going to hit the green second button, and then we're going to hit data again. And this time we want number 1 VAR statistics. All right. So to hit that number 1, you hit enter. And now on this next page, so it should look like this, you're going to hit enter 3 times. 1, 2, 3. All right, now you're going to scroll down and you want to know what is the minimum? What is the smallest number? So basically it's number 7, and I see minimum X is 35. So remember, we knew that because we just listed the data numerically. So I would write that down if I didn't have that information. Then I'm going to scroll down again. I want the lower quartile. I want the first quartile. And if you look at number 8, it says quartile 1 is 39.5. Then I want the median, which is number 9. The median, it tells us the median is 45. I also want the third quartile, which is, if you scroll down, you see 49.5. And then I want the maximum number of all of my data, and it tells me that the maximum number is 55. Now we know all that because we just did it by hand. And like I said, ours wasn't a big deal because there wasn't that many numbers in our data set. But if you had a lot of data, it would be very quick to put them into your calculator and let your calculator find those out for you. So keep these notes. So hopefully that'll make it easy for you. Okay. All right. So there was another set of numbers about this one. Try this. Make a box and whisker graph of the number of points scored by players on the basketball team. So try that both ways. Go ahead and do this by hand by following the directions. And also I want you to use your calculator, do the same directions we just went over, and write down the numbers when you get them, and come back to the video and see how you did. All right, so I just hit the word data and I'm typing in these numbers: 0, 0, 2, 6, 10, 12, 8, 4, 2. Now I'm hitting second data. I'm hitting enter for 1 variable. Now I'm hitting enter, enter, enter. All right, and I want to know my minimum. So I'm writing down my minimum. Oops, I need a pen. My minimum is 0. My median is 4. My Q3, my lower quartile, is 9. Oh, I missed my Q1. Oh well, Q1 is 1. My median's 4. My Q3 is 9. And then my max is 12. So I need a number line from 0 to 12. So 0, 2, 4, 6, 8, 10, 12. All right. And then let's find our median. The median is 4. Our lower quartile is 1. So we need our box to go from our lower quartile to our upper quartile. So our lower quartile is 1, our upper quartile is 9. There's our box. The line in our box points to our median. And then that's our box. Our whiskers are the minimum, which is a 0, and maximum. All right, so our Our box and whisker plot is skewed right. Our median's over here close to 4, far away from 12. This represents 25% of our data is between 0 and 1, right? The middle, 50% of our data is between 1 and 9. 25% of our data is between 1 and 4. And then 25% of our data is between 9 and 12. So yeah, you would say that this data is skewed right because most of the numbers are smaller rather than larger. All right, so how'd you guys do? I hope you did well with your calculator. All right, the next thing I want to talk about is mean absolute deviation. And mean absolute deviation talks about the spread of data. So let's say we had 4 students and they were all the exact same height. They were all 5 feet tall. Well, that means their average would be 5 feet tall or 60 inches. Let's say we had another group of 4 students and we had 2 really tall and 2 really short students. Well, if I took their height and averaged it, I might also get an average of 60 inches. But they would have quite a bit of variability in their heights. The first group, if they were all about the same height, there would be hardly any variability in their heights. The second group, even though the average might be the same, you would say that their heights are much more varied or spread out. So that's what the mean absolute deviation tells us. The bigger the mean absolute deviation, the more varied the data. The smaller the mean absolute deviation, the less varied the data. So how do you find the MAD? Well, the first thing you do is find the mean of the data. The next thing you're going to do is take each number and find the difference between the data and that every specific number. And the last thing you do is find the mean of those differences. All right, so we have 2 sets of data. So the first thing we're going to do in our calculator is figure out what the mean of each group is. So on the left, I'm adding in my calculator 96, 95, plus 70, plus 24, plus 25, plus 100, plus 20, plus 30 is 50. So I got 460, and 460 divided by 1, 2, 3, 4, 5, 6, 7, 8. Whoops. 460 divided by 8 is 57.5. All right, so the mean of the numbers on the left is 57.5. Now let's find the mean on the right. 40 plus 55 plus 57 plus 65, 65, 65, 55, and 58. So I got the same sum. There are also 8 numbers. And so the mean of each sets of data is 57.5. So let's pretend these were scores. These were grades. All right, so the first step was find the mean. The second step is to find the difference between each data set and the mean. So we're going to find the difference. Always you want a positive number, so you just subtract the biggest number, the smallest number from the biggest number. So the difference here is 38.5. You can do this with me. 37.5. 12.5. 33.5, 25, that would be 34.5, right? 100 minus 57.5 is 42.5. And then the difference would be 37.5. And then that would be 27.5. All right, folks, so step 1, find the mean. Step 2, find the difference between each data set and the mean. And then the last step is to find the average of the differences. So we're going to add together the differences, 38.5 plus 37.5 plus 12.5 plus 33.5 plus 34.5 plus 42.5 plus 37.5 plus 27.5 equals divided by 8. And the mean absolute deviation is 33. All right, so go ahead and pause the video and find the differences over here, and then find the mean of the differences, okay? All right. Oh, that one's not right. This is, yeah. Okay. All right. So hopefully we got the same numbers. I'm doing this fast. So if I make a mistake, y'all help me out. Okay. 17.5 plus 2.5 plus 0.5 plus 12.5 plus 12.5. It's not 12.5, you guys. 7.5. Just kidding. I can't even subtract with a calculator. All right, let's start again. 17.5 plus 2.5 plus 0.5 plus 7.5. 7.5, 7.5 plus 2.5 plus 0.5. I wrote 0.1. What is wrong with me? All right, so I got 46. Did you guys get 46? And 46 divided by 8 is 5.75. So hopefully we're close. If I made a mistake, please forgive me. So basically, if you notice, what happened is the average is the same. So let's say these are two different students. The student on the right and left both have the same average, 57.5, which is not good. However, the thing about the MAD tells you that the second student is a lot more consistent with his or her grades, right? On average, there's only about a 5-point difference in all of his grades. However, the student on the right, there's a 33-point gap on average of every grade from what they normally get, okay? So even though the means are the same, the first student's grades are much more varied. So that's what the mean absolute deviation tells us about, is how spread out is your data. So really, if you're going to form a conclusion about a population, you want a really small mean absolute deviation. If you're saying that most people do this on average, well, if you have a really small mean absolute deviation, that's probably true. However, you can come up with a mean of any set of data, but if the points are all over your graph, if the data is so spread out, that conclusion that you come to may not be valid. Okay, so that's what the mean absolute deviation tells you. How consistent is my data? All right, so did you hit your learning target today? So hopefully you guys practiced along with me. You made a couple of graphs, and now you could tell me a little bit about the mean absolute deviation. So anyway, if you guys have any questions or comments or any, if you need any help on your work this week, I hope you let me know. We're going to Zoom. This is for algebra. So we're going to Zoom Thursday, the 14th at 1 o'clock. So I hope to see you guys then. Like I said, if you need me before then, let me know. Have a great day.